subscribe.
Back on the portable test bench, and if I didn't already have enough sensors to calibrate, I'm about to add another sensor to the equation. In this package, I received a few packages in. The first one is from RACEWORKS, and the second is from Amazon. Let's pop these open and see what else I have to calibrate. First up, RACEWORKS. And this is pretty decent right here. Not referring to the lollipop, but that's cool also. This would be the support bracket for dual channel flex field mount. So this is pretty awesome. I did some research and I like the way the RACEWORKS flex field sensor mounting bracket is pretty nice. Very nice. It is set up for 10 AN, and that's the field line that we're running, and it actually flows more field than the 10 AN line. That's exactly what we need. We don't want to put anything restrictive on there. We want something that's going to flow exactly the same, or if not more. And this is more. So in this case, this is a lot better. And of course, in the next package would be the Amazon. That would be our flex field sensor. Let's see if we can get this out of the bag. I just ran a pair of scissors across. Here we go. And this is a genuine GM flex field sensor. So that's the way to go. We have this. We'll mount these pieces together. And we'll have a flex field set up for Teddy's TT. Awesome. Now, what I do need to make sure I have in stock are my dash 10 RB fittings that would connect in here. And also we have to set up where we're going to mount this. Our engine compartment is already crammed and cluttered and packed full of many items and products already. So we'll see if we can squeeze this in also. And the last package that fell out of the bag was our sensor connector also. So we definitely need that. This is manufactured by Continental. And this, as I stated before, is our original GM. This is the recommended sensor that a lot of people go for. Pretty much that's been tried and tested without any issues, and a great addition to upgrade for a vehicle that's utilizing flex field. That'll help us out with our tuning process. And one of the great things about this is allegedly Motec already have perimeters set up for using this style sensor. We'll get into the configuration with the Motec and see how that is. Back in the garage, I wanted to take a quick look to see what location we can map this bracket in for our flex field sensor. And something that I remembered also is our charging. We're at 100%, which is great. So check that out. That looks pretty good for the most part. Let's turn our fluke meter on and see what the voltage output is reading. 14 volts. And of course the real test is, let's disconnect the battery cable. And bingo, recovered. All right, so we're looking good. That part just dropping don't look good. We'll see. We'll see what it stabilizes at. But the battery itself, it started off at 7 volts and it's ramping down. Of course, it was getting pushed up. And we'll see what the baseline output voltage is of this. And it's ramping down a little bit slower without the trickle charger. Of course, it was doing a quick ramp down without the charger attached to it. And I'm kind of curious what our baseline is going to be. Hopefully, it's definitely nothing less than 12 volts, even though it's mentioned that a lot of these vehicles are 12 volt because you have pretty much a 12 to 14 volt operating system in your vehicle. But pretty much this will be for startup anyway. We'll see. And while this stabilizes out, we'll walk up and see if we can find a location for this baby right here. And as you can see, it's just trickling down slower and slower without the charge on there. Once we figure out the baseline, I'll still maintain the charge on here since this battery is not being utilized. And that's something I said is pretty good to use because pretty much that's what these are, battery maintainers. And for vehicles that's not being utilized that often or run on a daily basis, which this has been sitting in the garage far too long, and actually not necessarily garage, but sitting outside as a build project far too long, and then moved to the garage last year. But either way, we're slowly getting there. Let's move up front, see where we can map out and stick this flex fuel mounting bracket. Inside the engine compartment, I may switch a few things around. What I may do is reposition our fuel filter back a little bit and mount our flex fuel sensor up a little bit closer to our fuel rail. That way the filter will be back further. I may put a 45 on here. That way when it's coming up, it'll be a nice taper over, and then the line can pretty much keep straight across right here without too much of a bend. These are flexible lines, so it doesn't really matter too much. But at least it'll be somewhat of a smooth transition if I put a 45. Or we'll see how it looks whenever I get everything pretty much set up for that. Taking an overall look at the positioning in my engine compartment, what I may do is reposition our fuel filter. I will probably move this fuel filter back a little bit further, mount my flex fuel sensor bracket right in this location, going directly into the fuel rail itself, and maybe transition off of this side with a 45. So that way we have a nice smooth transition upward, tilting over, and that can come straight here. All of this can still move up and down and adjust, and of course our line is very flexible. We may not even have to use a 45, but we'll see. At least we'll have a baseline setup of where we're going to position this at and have a location. Of course, I would rather have the flex fuel sensor closer towards the fuel rail, put our filter further back, and then that way any type of particles and everything will be already filtered out before entering our flex fuel sensor, and we're not measuring contaminants along with temperature and the adjustment of our system itself. Mapping out a location for mounting the bracket for the flex fuel sensor, and there's a few things we can do. But for what's coming to mind at the most part, what I may do, I will reposition our fuel filter back a lot further and mount our flex fuel sensor directly before our fuel rail itself. I did check the stock. We do have some fittings. I'll post a picture of that. That will at least get us to set this up properly. This is set up primarily for -10 ORB, and of course you can reduce the sizes down to an 8 or 6, however you like. Our application is using -10. This works out perfectly for us. We'll put the -10 ORB on either end and pretty much connect that directly here, and possibly position our fuel filter coming up off of here somewhere and in this location. I have a nice smooth transition here. I could come straight up off of here, have the fuel filter along the side of the wall, this tower, and then put a 90. I want to eliminate the 90s for flow. You don't want too many restrictions, bends, and turns, even though we have 3 pumps that's going to be pushing a lot of fuel through the system. But of course, with a lot of restrictions, you potentially generate a lot of heat with bends and turns like that. You want smooth flow, smooth transition. So if need be, I can still allow this to flex up, and I would put a 45, something gradual, before I stick a 90 in this application and just let it come over. But for the most part, that's going to be the setup. We'll at least get this mounted somewhere over in this application here, in this position, and move this a little bit further back, and maybe just have them both come in position. And I just angle this down just a little bit, because as you can see, we have a nice little gap up in here between our return line and our feed line, and I can just level with this off just like this. Is pretty much straight at the bottom. That'll straighten this out a little bit also, and we can squeeze both in position and then just come off of here and flex into position. This may work out pretty good without looking extremely cluttered, but with the most part still looking somewhat aesthetically pleasing to the eye and not an eyesore with too much junk. At least we have a lot of high performance things crammed into this engine compartment. But the trick of the trade is making sure all of these work together in unison and to see how much power this thing will put out when we're finished playing with it. Back over here, our battery appears to have stabilized out at 12.6 volts. Not bad at all. It was initially starting off at 6 volts DC, which was extremely low. We're looking pretty good for the most part on this. This should be enough to possibly turn the start over and get the vehicle to kick over running. But either way, this will either be permanent or for temporary fix. We'll see once we get to that stage. We have a tremendous amount of other things to do, far more important than deciding on what type of battery we're going to use for the vehicle. But either way, Teddy had purchased this primarily for a little lightweight application when we're hitting a racetrack, because this vehicle, we've added a tremendous amount of weight to this vehicle than what it originally came with. The turbocharger application, all the heavy piping, the huge front mount intercooler on the front. It's a lot of accessories that's been added to this car, and we're still adding even more. But either way, we're going to go ahead, and you can see it's just hovering there. This meter is barely, of course, the meter is a load, but it's barely pulling any type of voltage at all. It's used as a reference for measurement, but technically it's still a load. If I was to leave this on, of course, it'll be a slow draw, not much at all. But 12.5, 12.6 is what it stabilized. As you saw at the beginning, it was dropping down quick until it got to a baseline setting, and at least we have an idea that it's definitely putting out a lot more than the 6 to 7 volts which it had drained down to. We'll go ahead and connect this back up, these clamps, and allow this to maintain itself. Set this up for deep cycle. It's going to analyze the battery and pick back up with the charging. And as you see, it jumped right back up to 14. So we're good to go as far as this. I dug through my box of fittings and pulled out what I need. It appears that I have everything that I need for the installation for mounting this FlexFill sensor support bracket. I pulled out plenty of fittings. As I stated, we should be good to go. We have 45-10s. We have some push on 10 AN straights. Here's another 45s that we have. I have another stubby short 45 for gradual transition. And these fittings flow very well, high quality, nice good quality. And as you can see, a nice smooth taper, no type of major lip that's causing any type of restriction. Put your O-ring on here. Put this in the package, and this should thread directly into here like that on either end. And then of course we mount our sensor in position. A spare O-ring did come in here also. They already have the original O-rings, or O-rings been installed in position as well for sliding this in. Take the hardware out, separate it, put this on both sides of here, and the O-rings will seal this up when you pull these out. Pop off with one hand, baby. And that'll be it. So let's see what we can do with getting this bad boy set up for here. I will go through the calibration first, and then that way this will be out of the way. One less thing on this test bench that's crammed full of parts. This will already be on the vehicle, and then we can start back playing with our fuel pressure regulator, high pressure fuel regulator for the direct injection pump, and a lot of other stuff. So I got a lot of different things up on here. This is the pressure regulator for the VR6 one. This one is a spare one that came off of one of the 4.2 V8s. Pretty much I would assume the same thing. I haven't measured or checked the part numbers yet, but we have a lot to do.